Taking another look at reference angles, now we're going to consider situations where our angles that are given, our theta is given, are greater than 360 degrees or 2 pi. So these angles have at least one, if not more than one, complete revolution within the angle. So to find our reference angle, the first thing we're going to do is find a positive angle less than 360 degrees or less than 2 pi. So what that means is, first thing that we're going to do is to pull out all complete revolutions out of our theta, and then just consider the angle that we have that is between 0 and 360 or between 0 and 2 pi. Then after we do that, similar to what we did with finding our other reference angles, we're going to consider the angle that we have now in standard position and look at that to find the reference angle, which is going to be that acute angle between the terminal side of our theta and the x-axis. So here is the first example we're going to consider. 665. Well, we can see from there that it's greater than 360. We have a complete revolution in there. So let's take the 665 and subtract out the 360 degrees. And that gives us 305 degrees. So we're going to be considering that angle. Let's take a look at this complete. So we know for 665, I'm going to do this in a lighter line so it doesn't make the drawing all that confusing. So there's how our theta starts out. We have one complete revolution, which we're going to basically pull out and ignore for finding our reference angle. Now from here, I'm going to continue this in red. So from here is our 360, and now we're going to go 305. So we go here to 180, we go here to 270, and then we continue to go here. 305 were less than the 360, so we're going to end up here. So this angle here, it's not our theta because we're ignoring that complete revolution, but this is the angle we're going to be considering, is this 305 degree angle for purposes of finding our reference angle. So the reference angle is between the terminal side of our angle and the x-axis. So this here is going to be our alpha, that angle in there. How do we find this? Similar to what we did before. We know that this is 360 and this piece here. So if we back out the 305 that we made for our angle, we'll find this alpha here. So alpha is going to be 360 degrees minus our 305 degrees to give us 55 degrees. So this is our alpha here, 55 degrees. Now let's consider finding a reference angle when we are given an angle of 15 pi over 4, which we know is bigger than a complete revolution. And knowing a complete revolution is 2 pi, since we're in the land of denominator 4, if we write our 2 pi in terms of a fraction with that denominator of 4, we see that a complete revolution of 2 pi would be 8 pi over 4. So again, let's take our 15 pi over 4. Where can I squish this in? How about here? So 15 pi over 4. Let's back out our complete revolution, our 2 pi, which looks like 8 pi over 4. And this gives us 7 pi over 4. So this is going to be the angle that we are going to be focusing on. But again, to show that here is one complete cycle in our original theta, there's our 8 pi. And from there, there's our 8 pi over 4. And then if I were to divide my pi's up into 4 to help give us a reference, we go another 7 pi over 4. So from here we would continue 1, 2, 3, 4, 5, 6, 7. And we are here. So here is our 7 pi over 4. Again, when we have an angle bigger than the 360 or 2 pi, essentially we ignore all the complete rotations that we've pulled out when we're finding the reference angle. And our reference angle formed between the terminal side and the x-axis. So this is our alpha here. To find the measure of this, we know that this is 8 pi, and we know that we've gone 7 pi over 4. So 8 pi over 4 minus 7 pi over 4 gives us pi over 4, which is alpha. And this is very similar to another example we did finding reference angles. So now this brings us to the last example in terms of finding a reference angle. So we have minus 11 pi over 3. So this says we are going in the clockwise direction. So if you look here, I've already marked this to give us some sense. Here's our pi, which, since we're in the world of a denominator of 3, would be expressed as 3 pi over 3. And our complete cycle of 2 pi is expressed as 6 pi over 3. So we can know where we're at versus our initial theta. So here we know we have a complete rotation because we can see our numerator of 11 is bigger than our numerator of 6 here. So let's back out. 11 pi over 3 minus 6 pi over 3 gives us 5 pi over 3. And again, we've done this before. I've mentioned this before. When we do our subtractions, we can ignore the negative sign here because it's just telling us direction. So for purposes of subtraction, we don't need that negative sign here. So now this says we are going 5 pi over 3. But now we can't ignore the fact that we are going in the clockwise direction. So here we would start here. There's one complete rotation there. There's our 6 pi over 3. And now we're going another 5 pi over 3. So if I were to try to divide this up into, here's 1, 2, 3. My thirds aren't so great. Let's see if I do better up here. 1, 2, 3. So I've divided my pi up into 3. So from here, we know that we're going 5 pi over 3, and we're going in the clockwise direction. So here's 1, 2, 3, 4, 5. So here is the angle that we have created. Again, we are looking for this reference angle, this angle between the terminal side and the x-axis. So here is our alpha, our reference angle. And to find this, we know we've gone almost a full 6 pi, but not quite. So we take our 6 pi over 3, and now we back out the 5 pi over 3 that we have used to make our angle, and this leaves us with 1 pi over 3, which is our alpha.